Exponential expressions look like this. So far in the videos, I've been talking about exponential expressions where the base is greater than 1. Why do you think it matters if the base is greater than 1? What would that change? I want you to think about it for a second. You can test some different numbers. What happens if you have 2 to the 5? And what happens if you have 1 half to the 5th? Use a calculator if you need to. Let's go ahead and take a look at the graph when the base is greater than 1. What is going on over here when x is negative? We talked about this in another video. Do you remember what happens here? As x goes to the left, so as it gets to be a larger negative numbers, the y goes to 0. Let's talk about why that is for a second. Let's look at the specific example of when we have the graph of y equals 2 to the x to see what happens over here at the negative x values. Let's start when x is negative 1. So we are going to have 2 raised to the negative 1. But what does this mean? How do we deal with a negative exponent? In another video over properties of exponential expressions, I talked about how if you have a negative exponent, that means that that base raised to that power is in the denominator, like this. 1 over 2 is 0.5. And if x is negative 5, now we plug in negative 5 into 2 to the x. And since we have a negative exponent, we just bring that down to the denominator and divide 1 over 2 to the 5. And we get 0.03. So we are getting close to 0. And let's do one more where x is negative 10. And doing the same thing, pulling that negative exponent down to the denominator, we get 1 divided by 2 to the 10th, which is going to be a really small number, right? Because we are dividing by a really large number. 2 to the 10th is a large number, so we're dividing by that. It's going to be so small, it's almost 0. If you divide that out on a calculator, you see it is 0.00097, which is super close to 0. So all of these are tending towards 0 because we keep dividing by a larger number each time. And dividing by large numbers makes smaller numbers. Think about 1/4 is smaller than 1/2, right? Or if I said 1/8, you would know that's smaller than 1/4 because 8 is a bigger number than 4. Okay, so take a moment to look at the graph and what is happening when x is negative. We are dealing with fractions, right? 1 over 2 to the 1, 1 over 2 to the 5, 1 over 2 to the 10th, etc., as we just went over. So when we have fractions less than 1, so not like 3/2, but 2/3. When we have fractions less than 1 raised to powers, they are going to approach 0 as those powers get greater, right? Uh, so what if the base is less than 1 and greater than 0? We haven't talked about that, but all of these are also greater than 0. That would be, for instance, 1/2 to the x, or 1/4 to the x, 2/3 to the x, etc. So now we are going to be working with exponential expressions like this. Notice this does not include all fractions. Like 3/2 is not included because it is greater than 1. Let's look at the graph of 1/2 to the x. So now our base is less than 1. Do you notice anything different about this graph? Let's put the other graph up here so you can look at the differences. This over here on the right is the graph of 2 to the x. What is different about the two? They look like reflections of each other, don't they? So on the graph to the right, when we have 2 to the x, it tends towards 0 when x is negative. What about this graph of 1/2 to the x? When does it tend towards 0? Over here is where 1/2 to the x tends towards 0, where x is positive. Why does it tend to 0 when x is positive? Let's take a look at y equals 1/2 to the x and plug in some values to see what happens. When x is 1, we get 1 over 2, all raised to the 1, which is just going to be 1/2. When x is 5, we have 1/2 to the 5th power. So that 5 goes to the top and the bottom. So we have 1 to the 5th over 2 to the 5th. So that is just 1 over 2 to the 5th. This should look familiar. This is the same thing we were getting when we had 2 raised to the negative 1 and 2 to the negative 5, right? Because that meant we just moved the 2 down to the bottom, so they were the same thing. So we get 0.03125 when x is 5. And when x is 10, we will get that 1/2 to the x is 1 over 2 to the 10, which is 0.00097, which is the same that we found earlier when we were talking about 2 to the x, where x is negative 10. So we can see when our base is less than 1, but greater than 0, we are getting smaller and smaller as x moves to the right. It is approaching 0 because we are dealing with large numbers in the denominator of the fraction. So when the base is a fraction less than 1, what's happening over here on the left, where x is negative? We can see that it is growing. The y values are going up as x gets more negative. Do you know why? Let's look at when x is negative 1. So now we have a negative exponent, but we have 1 over 2 raised to the negative 1. Just a side note as a reminder, when we have a fraction raised to an exponent, the exponent gets applied to the numerator and the denominator. So that negative 1 gets applied to the top, but 1 to the negative 1 is still just 1. And it gets applied to the bottom. So we have 1 over 2 to the negative 1. But what do we do when we have a negative exponent? We can just flip it to the other side of the fraction, right? So that 2 to the negative 1 on the bottom is just brought to the numerator. And we have 2 to the 1. And when x is negative 5, we are going to have that negative exponent, and we flip it. And when our x is negative 10, we end up with 2 to the 10 after flipping the negative exponent. So we can see that when our base is less than 1, it grows for negative x. It just does the opposite of what happens when the base is greater than 1. So we talked about the base being greater than 1, and we talked about the base being less than 1, and always greater than 0. So let's just quickly talk about what does it mean for the base to be equal to 1. Let's consider the exponential function with base 1. And let's plug in some x values: 1, 5, 10, and negative 5. It doesn't matter what we plug in. What are we getting back every time? We always get 1 back, right? So this is a constant, and it doesn't share those increasing and decreasing properties. Now, what if our base is negative? We can plug in 2 for x. We get negative 1 squared, which is 1. And if we plug in 3, we have negative 1 cubed. So far, so good, right? What if we plug in 1/2? What does that mean? So I cover this in another video. So if you're unsure, you can check that out. A 1/2 exponent means square root. So we have the square root of a negative number. But we can't do this, can we? Remember, we can't find square roots of negative numbers unless we are also working with the complex numbers, also sometimes known as imaginary numbers. So for a lot of classes where we don't work with imaginary numbers, we don't really use negative bases because we wouldn't be allowed to enter just any value for x. A lot of values we entered would cause problems like this. So that is it for the exponential functions with bases less than 1. I know these videos have been a bit long, so I really appreciate it. Thanks for sticking around, and I hope you have a great day.